All right, number 1 says graph to find the solution to the system. So first we need to graph the first equation. So I'm going to go to -3 and put a dot. That's my y-intercept. My slope is 2. It's 2 over 1. So I'm going to go up 2 to the right 1. Remember, when you're starting out, you always go to the right. Up 2 to the right 1. Up 2 to the right 1. We need as many points as we can right now. Down 2 to the left 1. Down 1, 2 to the left 1. All right. Now I'm going to do the other one in blue. I'm going to start at -1. This time the slope, there's not a number in front of the x, but remember that is 1. So I'm going to go up 1 to the right 1. Up 1 to the right 1. Up 1 to the right 1. Ding, 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 ding. Up 1 to the right 1. And so right here is my solution. Yes, I heard it out there. It is 2, 1. 2, 1 is your solution. Number 2. The two systems are represented with values in tables. To determine, it says determine the solutions of each. Okay, well, I'm going to look. When we're looking at this for system A, right here, y1 and y2 are the same. You should have gotten the answer to be 2, 3. In system B, where do y'all see it? Oh, they're not the same anywhere, are they? If they're not the same, there's no solution, none. Okay? You were keeping going, writing it down? Okay. Nope. If it doesn't give you, I mean, if it's one of these and it doesn't give you the equation, then you're just going to have to go off of what they give you. All right, number 3. Which of the following graphs best represents an equation that has no solution? If they have no solution, what does that mean? Parallel. They are parallel lines. And so, yes, the answer should be B. Number 4. Let's grab our handy-dandy calculator. Yeah, actually, somebody just said the answer before we ever even did anything with it. When I go in here, 3x minus 2. 3x minus 7. If you know anything about the equations, you can already see that the slopes are the same. If the slopes are the same, what type of lines are they? They're parallel. So what kind of solution do they have? No solution. Number 5. Well, this one's not parallel because they have different slopes. So let's look at that. Let's go in here and put in there x plus 4 and 4x plus 1. I'm going to press graph first. You don't have to. I'm just going to see if I see it. Looks like it's right here, but you need to look in the table to make sure you can find the correct number. I heard somebody tell me it. It's 1 and 5. So 1, 5. All right, so look at number 6. Are these two lines going to be parallel? No, because these slopes are not the same. It's 0.2 and 0.4. They're going to be rather close, though. So let's go in there and put in there 0.2x plus 3.5. 0.4x plus 9.5. Now when you graph, remember this is not parallel, but now I need to look in the table. It's going to be some kind of negative number, but the problem is I don't know if we're actually going to find it on here. Let me show you, instead of looking through the whole table, here's an easier way. You're going to press second and trace 5 for intersect. Press enter 3 times. 1, 2, 3. Oh, it says error. So I'm going to do this. I'm going to zoom. Well, let me go back to graph. Zoom out. This is one way you can do it. And press enter. Somebody told me the answer, but you just look through the table. Second trace, 5 for intersect. Enter 3 times. 1, 2, 3. It tells me it's negative 30 and negative 2.5. See, if you went through the calculator and kept looking, here's negative 30. You would see that it's negative 2.5. So my answer is negative 30, negative 2.5. Number 7. Paulina wants to purchase jelly bean candies for a friend. The cost for jelly beans at Fun Factory is $8.99 per pound, plus an additional charge of 75 cents. Candy World charges $9.50 per pound with an additional charge of 25 cents. Which system can be used to determine when the companies charge the same amount? One of them, Fun Factory, starts and it charges $8.99 per pound with an additional charge of 75 cents. It's not B that has the 75 with an X. This isn't right. It says 8.99 plus 0.25. This one has a 75 with the X. C would be the correct answer. This one looks kind of crazy when you're trying to read it. What I need you to do is I need you to read the problem, and I need you to figure out which one of these answer choices you would choose. Before you go on this problem, wait for me to come back and make sure you have the right one. So on this problem, it says Sarah and Maddie are running around a quarter-mile track. Okay, that's all the tracks that are a quarter mile. Remember, that's 1/4 of a mile. Sarah got to the track early and completed 3 laps before Maddie joined her. Which system could model the distance in miles each girl completed in T hours? How many people chose B? Some people don't want to tell me? Okay. How many people chose C? How about A? Okay, now, B is where they're trying to trick you. It wants to know in miles. Guys, in miles, how far is 3 times around the track? 0.75, right? You have the first time around the track is a quarter mile, the second time it's a quarter mile, and the third it's a quarter mile. Now, B would be the right answer if it told you the distance in laps, because that's saying 3 laps. This is saying 0.75 of a mile. So yes, the answer should be A. Now, according to this system that we selected, what pace, miles per hour, was each girl running? So what they're asking you for is, what is the slope? So Maddie, well, who got to the track early? Sarah. So Sarah is this first one. How fast is Sarah running? 9. No, 0.75 is how far she's already run. She's running 9 something. Okay? And then Maddie is running with 10. All right? What is the solution? So now let's grab our calculator. Put the 2 equations into y1 and y2. So I have 9, that's not a 9, try that again, 9x plus 0.75 and 10x. Second graph. I think I got to go back to the positives here. Where are they going to run the same? After how long? Does it happen? Let's see. Second, I'm going to go to trace. 5 for intersect. It's always easier to do it this way. And enter 3 times. This is why I like, and actually it asks you what does a solution represent, but the actual intersection, if it was a decimal answer like this, you have to do that 3 wishes that I just did to find it. See, it is 0.75, and what was the other number? 7.5. What does the x, well, we have t and we have d. So it says in 0.75 hours, what's 0.75 of an hour? It's 3/4 of an hour. What's 3/4 of an hour? 45 minutes. So in 45 minutes, they have both ran 7.5 miles. That's what our solution is saying. Okay, please do number 9. All right, number 9 says, Hayden purchased 2 drinks and 3 hot dogs from the concession stand for $9. Lexi purchased 3 drinks and 5 hot dogs for $14.50. Which of the following systems represents the cost of each drink, D, and the cost of each hot dog? So first off, Hayden got 2 drinks plus 3 hot dogs, and that equaled $9. So that one works like 3. Oh, what does this say? 3D. What is that? I don't even know. That's not it. 3D. Nope. I don't even have to go any farther. All it was A. The next one says, which of the following equations will form a system whose solution is 3, 5? So first we need to check and see if 1 and 2 do. Then you need to check 1 and 3. And then you need to check 2 and 3. So, it's difficult to do them all at the same time. Well, you can. I mean, if you can read through all that stuff, then yes, you can. For me, I'm going to do it 2 of them at a time. I'm going to start here and go 2x minus 1. And then I have 1/3 x plus 4. I'm going to press second graph and look and see if 3, 5 is a solution. 3, 5, 5. Sure is. So 1 and 2, this one works. So let's see here. Let me mark it. This one works. Now when I go in here and I put in 1 and 3, so get rid of 2. What's 3? 4x what? Minus 2. Second graph. 3, 5, and 10. Nope, that doesn't work. So this one doesn't work. What about 2 and 3? I don't think that one will it? Oh, come back. Yeah, I think it's just 1 and 2. What about you guys? Did you guys get 1 and 2? Yeah, because 2 and 3, nope, that doesn't work. So yeah, the answer should just be 1 and 2, which is answer A. Number 11. Now, look, some people tell me there's no solution to this. You have to continue your lines, don't you? So if I continue my lines, let's see, what's this line going up by? Up 2 over 3. Up 2 over 3. So that one continues like that. Oh, man. Okay, nice line. What's the slope of this one? Up 2 over 1. Up 2 over 1. Up 1, 2 over 1. Up 1, 2 over 1. Up 2 over... Ding, 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 ding. What is that? That's 9. 9. There we go. 9, 9. Bang, bang. All right, so it's 9, 9. So all you have to do is continue your lines and find where they intersect. Whoop. All right, on the back of your sheet right here, it's giving us a graph, and it's talking about the time in days and the height of a balloon. And it says, write the equation to represent the height of balloon A over time in days. Okay, so we're talking about balloon A. Balloon A, first off, we need to find for balloon A, what's the starting point? Point A, or line A starts at 10. So my y-intercept is 10. What is it? It's going down, but what is it decreasing by? So we need to find the rate of change. So let's see. If I go here to 1, does it cross in an exact point? Right here. It's going down 2 and over 1. Down 2, well, 1, is it? Down. Oh yeah, down 2 over 1. So I'm going down 2 over 1. So your equation for balloon A is y equals 10 minus 2x. Well, I guess I could do h. H equals 10 minus 2t. 4. Oh, but wait a minute. You guys are talking about 4 lines, right? But look at 4 lines. Each line is going by a half. Okay, but I'm really glad you said that, because that's where people get confused. They think that because they look and they forget to look at the numbers, they just look at the number of lines. You have to figure out what each line goes by. See how right here it's going up by a half? That's why when I'm going down 4, I'm looking at my numbers. I'm actually going down from 10 to 8, which is down 2 and over 1. So it's a great point to make sure that we don't make that mistake. Balloon B starts at 6. So my y-intercept is 6. Now my slope here, I'm going to go over here to 1. I go down to 5 and over 1. So my slope is negative 1 over 1. So my equation for balloon B is y equals 6 minus 1x, or if I did h, it'd be h equals 6 minus t. Either way you could write it. Now, it says, what is the solution to the system? I want you to put a dot where the 2 lines intersect. Right here. All right, so right here is where the 2 balloons intersect, which is over at 4, 2. 4, 2. Now it says, what does that solution represent? 4 is the x. What's on the x-axis? Time. So it's going to be 4 days. The balloons, both balloons are at 2 what? 2 feet. Then it asks us, when will the balloon land on the ground? Balloon A, this line right here, balloon A is going to land in 5 days. Balloon B doesn't land till 6 days. Now, 16 says, what is the y-intercept for balloon A? The y-intercept right here is 0, 10. The y-intercept for balloon B is 0, 6. It says, what does the y-intercept tell you about the balloons? The height that they're starting at, right? So this is the starting height. Now, which balloon is falling at a faster rate? I hear people saying A. How do you know it's on the graph? How do you know it's falling faster? Because the line is steeper. And how fast is the balloon falling? 2 feet per day. Okay? Not as worried about 18. You guys need to write a story that would match a description of what's happening in the graph, so you guys can come back to that. Look at number 19 and 20. Take a minute and answer number 19 and 20. So on number 19, the system, they want you to write what the system is. They want you to look at the graphs. They're not asking you what the solution is. I mean, if they ask you for the solution, that's that point right there, which is 2 and 14. But they want to know the system, so they want you to write the equations. So this equation first, it's starting off at 6. And you have to find the slope. Now, one of the things I like to do, because see, these lines are going by different amounts and halves and stuff, is I go over here to 1, and I go up to my line, and I look and see, does it cross at an exact point? And it does. So now I'm going from 6 to 10, so I'm going up 4 and over 1. 4 over 1 is 4. So one of my equations is y equals 4x plus 6. The second equation, I'm starting up here at 10. So that would, the y-intercept would be 10. So again, I'm going to go over to y, go and see if it crosses nicely, and it does. I'm going up 2 and over 1. 2 over 1 is 2. So my other equation would be y equals 2x plus 10. So when it says a possible situation, they want you to come up with a story that matches this. For example, you could say that, I don't know, we were growing two plants and trying to see when they would be at the same height. And I would say that plant 1 was 6 centimeters when we started. And plant 2 was 10 centimeters. We gave plant 1 fertilizer, I guess, Magic Grow, to see if it would work. Plant 1 grew, where'd my thing go? There we go. Grew 4 centimeters per day. And plant 2 grew 2 centimeters per day. I could then write, when were they the same height? Now on number 20, all they want you to do is write the system. They're not asking you to come up with the solution, but we'll talk about that in just a second. The tortoise. For the turtle, how fast is he going and when does he start? He started at 5. How fast is the tortoise going per hour? 4 miles per hour. Now the hare started at 0, and it is going 6 miles per hour. To write the system, I have y equals 6x. You could write plus 0 if you want to. The tortoise, y equals 4x plus 5. Now, the solution is not given here on the table, but you could put this in the calculator and find out what the solution was. But they want you to write a situation that could describe this table and these equations. And that's what they're asking you to do.